Hello everyone, I am Dr. Abha Kumari, Assistant Professor, Department of Mathematics, Nirmala College, Ranchi. Today we will discuss the linear differential equation of higher order with constant coefficient. In this topic, first we will discuss the homogeneous differential equation of higher order with constant coefficient. For this, let us see some theorems and examples. A partial differential equation with constant coefficient. Homogeneous linear equation with constant coefficient is the second topic while we are discussing about the constant coefficient. Earlier we have seen the differential equation with constant coefficient only in one variable. But here we will see the differential equation with constant coefficient in two variables x and y. So a homogeneous linear equation with constant coefficient is defined as a linear homogeneous partial differential equation is of the form where all derivatives are of the same order, such as del n by del xn plus a1 del n minus 1 z by del n minus 1 x and del y, this one, plus a2 del n minus 2 z by del n minus 2 x del y2 plus up to an del nz by del yn equal to fxy. This implies we can write here del z by del x as d. That's why del nz by del xn we will write it as d to the power n plus a1 d n minus 1 and then d dash. Here we will write d dash for del z by del y and d for del z by del x. So the function a2 dn minus 2 into d dash square plus up to an d dash n bracket close z equal to fxy. This implies this whole function can be written as phi d dash z equal to fxy. Then the auxiliary equation. How can we obtain the auxiliary equation of these functions obtained? So we will put d equals to m and d dash equals to 1 in equation number 1 here. In this equation we put d equals to m and d dash equals to 1. So the equation 1 becomes phi d dash equals to 0. And therefore m to the power n plus a1 m to the power n minus 1 plus a2 m to the power n minus 2 plus up to plus an equals to 0. So here first we discuss the two cases. The first case when the auxiliary equation have equal roots but the roots are unequal. Equal have equal roots, that means unequal. Here it is unequal roots. We have unequal roots. So let m1 m2 mn are the roots of the auxiliary equation. Then the CF part can be written as z equals to f1 y plus m1x plus f2 y plus m2x plus up to fn y plus mnx. Here we write earlier if we have a function and auxiliary equations are m1 or m2, we write the equation CF part as y equal to c1 e to the power m1 and c2 e to the power m2. But here in this function there are two variables x and y and the function are given in z. That's why we will write the CF part as z equals to First equation is m1, m2, and so on up to mn. Therefore, z can be written as f1 y plus m1x plus f2 y plus m2x and so on plus fn y plus mn x in this order. So we write the equation of the comp CF as this way. Now case 2, when the roots are equal. When the roots are equal, we write it as the multiple of x squared xq like this. Earlier when the roots are equal, what we will write? We write as y equals to c1 plus c2x and then e to the power mx like this. But what we do here is, here we can write the repeated term in terms of function. So z equals to, here what we will write here is z equals to, first is your f1 y plus mx. So here we will put this function x and again we write f2 y plus mx plus, if the 3 times repeated root, then we use x square f3 y plus mx. If it is 4 times, then we will go for the f4 y plus mx and so on. So here it is for the function of n repeated roots. That's why we will write the last equation as x to the power n fn y plus mx. So let's see an example of this question. So solve 2r plus 5s plus 2t equals to 0. So let us first see what this r, s and t are. So r is del 2 z by del x2 is known as r. S is del 2 z by del x del y and t is your del 2 z by del y2. So here we use, if we have a differential equation of the form del 2 z by del x2, we will write r. If we have del 2 z by del x del y, we will write s. If we have del 2 z by del y2, we will write t. So here the given equation is of the form 2r plus 5s plus 2t equals to 0. Therefore, the auxiliary equation of this question is 2d square, where d is what? Del by del x plus 5d d dash. So we will use d dash for del by del y. So we can write is del 2z by del x del y as del z by del x and then del z by del y. But since it is a partial order, so we can write like this del 2z by del x del y. And that's why we have written here 5d d dash plus 2d dash square and then we have z equals to 0. So while solving, its auxiliary equation is 2m square plus 5m plus 2 equals to 0. Here we have put it d equals to m and d dash equals to 1. So the auxiliary equation is 2m square plus 5m plus 2 equals to 0. While solving this equation, we get 2m square plus 4m plus m plus 2 equals to 0, and this will give the value m plus 2, 2m plus 1 equals to 0, and therefore m equals to minus 2 and minus 1 by 2. Therefore, the complementary function can be written as, since m equal to minus 2, that's why we will write here CFS z equals to f1 y minus 2x. For this minus 2, we will write it as minus 2x here, and for minus half we will write y minus x by 2. So this is our complementary function when y equals to minus 2 and when y equals to minus half. We will write f1 y minus x by 2 and f2 y minus 2x. Let us see some another example where solve r equals to a square t. So here we will write this equation as del 2z by del x del y equals to a square del 2z by del y2. And when we take this one as in the left hand side, we have the value del 2z by del x del y minus a square del 2z by del y square equals to 0 of this form. Therefore, its auxiliary equation will be m square minus a square equals to 1, and this will give the value m equals to plus minus a. So its complementary function is z equals to f1. For the plus a we have y plus ax, and for the minus a we have f2 y minus ax. Again, see the some other questions, since these questions are asked for the short questions with the 2 marks or 1 marks. So next question is solve del qz by del x cube minus 3 del qz by del x square del y plus 2 del qz by del x del y square equals to 0. So first we write this auxiliary equation as mq minus 3m square plus 2m equals to 0, and by solving this we have m square minus m minus 2 equals to 0, and this will give the value m into m minus 1, m minus 2 equals to 0, and here we are living with the value m equals to 0, 1 and 2. So its complementary function, we will write it as z equals to f1. First is y plus mx, but m is what? 0. So m plus 0 x plus next is f2. So f2 y plus 1 into x and plus f3 y plus 2 into x. So what we get the value as? So y equal to f1 y. So here we get the value as z equals to, sorry, so we get the value as z equals to f1 y plus f2 y plus x and plus f3 y plus 2x. So this will give us the CF part of this function.